Welcome to Boston Fintech Week. Are we? Great. Very happy. We're thinking about it already. I'm Sarah Miller, and I just want to give you a brief welcome. We're giving the whole picture out. Every amazing attendance. Thank you all for coming. It's my job tonight to really welcome you, but also thank our sponsors, which includes staff and the GSB Labs team. It's amazing that they have actually brought us all together here. Thanks again. They were really thoughtful with the way they constructed tonight. I just really think about the content. I know me on behalf of the Boston Fintech community, say thanks to all the panelists that I think you introduced. And I want to thank you for your moderation and work tonight, and the other members of the Boston Fintech team, Pharma, where is he, and Julianne, who greeted you downstairs. She may still be downstairs. She's just coming out. So if you all see them, thank you. And this is a volunteer group, and we're very thoughtful. We also are live streaming tonight. We have a YouTube channel set up for Boston Fintech. So if you ever want to go back and revisit this event, please do so. And where are you with Unitalk? We could not do this without you. He's also in the back. Thank you. So thanks, everybody. See you later. Conversation around AI. Thanks so much, Denise. Thanks for having me. Nice to get a chance to see Sarah. And you know Sarah, she's always busy, so cornering her somewhere like here is nice catch up. So really happy to be here. My name is Jessica. My background is in the research and finance space, but for the last 6 months, what? I'm not talking about that? Unusual for me. Okay. I don't want to scare the front guy. So background is in quant finance. For the last 6 months, I've been moved out of the sort of real full-fledged startup space where I was working at a company locally called Quantopian, and I joined Fidelity Labs, where we're still trying to start new initiatives, but inside of a corporate innovation group at Fidelity. So thinking about how the firm can look into the future and think about where new fintech businesses will be launched that will be relevant to our customers.
Thank you, Jason. Thank you for having us here. I'm Ashok, and I work for Man I'm in the quant finance world too. For those of you who do not know, Man Numeric, we're into active asset management business, and we are primarily focused in global equities, stock selection, with a focus on fixed income as well. I've been in the firm for 6 years now, and I'm a quant researcher there. So most of what we are talking about, like machine learning, everything, we use, like, I'm one of those researchers using those models in terms of building automated stock selection model. We'll talk more about it in the panel.
Okay. Hi. Hi, I'm Caroline Sherman. Thank you for giving me the chance to have somebody else just to speak louder. very, very unusual the first, I think. Anyway, and Caroline, obviously, I know Jess, currently, or most recently, was Chief Product Officer at a company called Quantopian. For those who don't know, Quantopian is a fintech company in the quant finance and tech space, with both an asset management arm and a software business. Just by way of background, I'm sure most folks can relate to this. I sort of lived my life cutting between finance and technology. I started my career in GSAM and quant. I was doing portfolio management there, as well as a bunch of client-facing work. It was through the financial crisis, so things were changing quickly. I spent most of my time rebuilding risk models, not really getting to look for any alpha, but that was the right use of time at the time. And then I actually went into government. So for anyone interested in regulatory work and kind of how that interplays with machine learning and AI, spent a bunch of time working on things coming out of the Dodd-Frank bill during the time when Meitner was there. And since then, I've had sort of much more focus on technology. So is it a product, or is that even product at a data analytics startup locally, and then joined Quantopian. So I'm sure many can relate to that, but I love this intersection of fintech, and I'm very happy to be here.
So just please, I just wanted to reiterate, thanks for having us. We're really excited for this panel. We're really excited to be here and forward to engaging in the discussion. I'm Andrew Kinman. I'm with the Research Technology Group at M.B.A. So we sit a little bit between the research and the technology portions of the organization. We focus on building a platform that, as we think of it, tries to lower the cost of innovation, particularly for stock selection, for portfolio construction, for data analysis and risk modeling. That's sort of what I will bring. I come from a finance and economics background rather than a computer science background, but I've been with the software team for 5 years or so at Numeric. So maybe that's my new life. So our offices are in Seaport. Our main Numeric offices are in Seaport. We're a London-based firm, Man Group, with offices in London, Charlotte, New York, Boston.
If you can't hear us in the back, anything you want to connect with? Can you hear it? Okay. All right. Well, thank you very much for the introductions. For anyone who doesn't know, I'm Denise Johnson. I'm the co-organizer of the Boston Fintech AI in Boston Fintech. I have led the technology operations of the quant shop here in Boston for 8 years. And then worked at State Street as head of data and digitization and alternatives, and then have been working with startups and emerging technology, and most of you have seen me in the Boston Fintech community. So, jumping into the why we are here today. So, as the speed in which technology is changing and the access to our data is increasing, the institutional investors' work has been changing significantly and drastically. So we're here to unpack the role of machine learning and artificial intelligence in the race for alpha and data analysis and backtesting and construction, as well as trading. So one of the things that when I think of machine learning, I think of quants immediately because they have been always on the forefront of adopting newer technologies in the way to be more competitive, to get to an alpha faster. So I wanted to start with that first. So we're seeing much more adoption of the AI technologies in the quant shops right now, but I'm going to turn it over to the panel about where do you see the most impact on AI technologies? Do you see them in, could you give me some examples of use cases in quants versus fundamentals? Or, because we have all quant backgrounds, maybe start with the quants and what is the most impactful AI use case that you see?
I kind of want to hand it over and see what you guys are going to talk about.
So it's kind of fascinating. Like this is, I believe we have been given a gift of watching this evolution of AI usage in quant from the front seat. I still kind of remember when I joined this industry in the first place, I was given a very simple project, and I took almost a 1 month to complete the project. It was just we were taking a survey of how the sell-side brokers were performing, how their research is, and my boss wanted me to just summarize the survey. I took 1 month to summarize it. I made a robust framework. I made sure there was no outliers and etc. And then my boss, after 1 month, he yelled at me, and then he said that he quoted a line from Emanuel Derman's book and said that 90% of the time it is addition, subtraction, and multiplication. If you are dividing something, then probably you are doing something wrong. You have to pay attention. So I believe, the basic arithmetic operations and ordinary least squares and maybe PCA has been ruling the quant world for a long time because it's kind of simple, robust, and, it gave us very intuitional results and etc. And then I believe that something happened along the data landscape. Like There was a certain exploration of the data available. There be sales data, location data, shipment data, text data, especially because all the numerical data, we had kind of some toolkits to work on it. But when the text data came, we were sort of toolkits to work on it. Then we started counting words, like, let's take the filings, company filings, and then let's count positive and negative words. And then came the Twitter. Oh, how can we, Elon Musk is tweeting. How can we count the positive and negative words and then form a signal? No, you need advanced algorithms to do it. Right? Then I believe, Quant started taking into account, okay, we have to really start using the machine learning if we want to harness this data. And then we started seeing some of the results in terms of how we can use machine learning or AI, everything to harness the text. Once we got comfortable with that, then, we are turning back and then say that, oh, by the way, we had this traditional data, which we were using linear algorithms to find linear patterns. Now, can we use these advanced algorithms to find some nonlinear patterns? Oh, yes, it seems to be finding patterns. Now, there is a lot of conversations around overfitting and etc., but it finds a pattern and it seems to be working. That's where I believe we are, slowly starting from it's more propelled from the data. Text was, in my opinion at least, text was the first evolution propelling us to adopt it and getting into the alpha generation. And now people are using it for trading, in the risk model development or whatnot, actually. That's been quite fascinating to see the adaptation, actually.
So great overview. That was awesome. I think what I can maybe bring is having come from a quant background, and I now, 6 months in, have been at Fidelity. I actually see one of my colleagues sitting back there who actually does machine learning and AI modeling on a day-to-day basis, so he can keep me honest. But we're not a quant shop, right? We produce some quantitative signals, but really we still have actual discretionary portfolio managers. So one thing that's been really interesting for me to see as I've come in and learned what our AI Center of Excellence is focused on. There's a lot of process automation stuff that can be done. There's a lot of text that can still has been digitized. There's also interesting stuff that's not even in the asset management side that I think is really interesting. Just looking at Fidelity is a huge customer base we need to serve, and the cost associated with serving those customers and taking phone calls and sort of knowing where to route them, what ads to serve them, what the call volume is, how the chatbots should work. There's this huge body of work at the firm, which I think we're making what looks like to me pretty interesting inroads into using machine learning and modeling in those places. So what's cool is to go from where I think in Quantland, there's so many challenges with non-stationarity of data and creating these models that you're sort of trying to make sure that you validated them and they're not overfit, and you've got to kind of keep fitting them online. And then I think there are a little bit of simpler problems that we can look at in terms of a big, largely long-only asset manager who's, if we can find process automations or efficiencies, even if those efficiencies end up being things that save the asset management portfolio team time, those are viewed as being really valuable. So a lot of the projects that I've seen that are sort of already being implemented or already in production at Fidelity are in that process automation and efficiency space. I've seen a bit of that.
Yeah, so I think one thing that's very interesting is I think there's kind of no part, and I think Jess alluded to this, there's really no part of the sort of investing process or sort of no aspect of finance that won't benefit to some extent from this explosion of data. And the critical thing I think you're also highlighting is you have to be very smart about it in order to be effective. You can't just sort of willy-nilly say, like, let's just add data to this situation and do something interesting with some machine learning model. I know people have tried to use sort of plug and play software to say, like, random forest, like, what does this tell me? And that just doesn't get you very far if you don't know what you're talking about or what you're looking at. And certainly if you don't understand your data from the get-go. One very interesting place that I've seen it come up a bunch, especially in the context of Quantopian has been selling its software to financial institutions. And the question is kind of who needs that off-the-shelf version of a backtester and a way to work with data. And it turns out there are a lot of firms who have traditionally been more fundamentally focused and still to this day have large teams of what we consider traditional stock pickers, people reading the newspaper and meeting with management and inspecting the details of the company themselves. who will benefit from adding an overlay of some sort of quantitative view. And so what they've done at a lot of these firms is built a team. They'll sort of bring in a few data scientists or quants. They kind of don't know like which background exactly do they need or want, but they want to be able to smartly apply data to their process. And I think this is sort of an interesting part of the evolution where I think we're all relatively, a process steeped in traditional quant, or what we consider quant, and sort of building signals and models and just approaching it that way from the get-go. Now there's this interesting opportunity for a lot of firms, a lot of companies to overlay that kind of work. And then the question is kind of how do you start to combine that? And that's, I think, one of the really interesting sources of IP is like, how do you actually take advantage of all that sort of interesting modeling and actual interesting data and make it valuable to your existing process?
Yeah, so one thing that Caroline said that stands out is that you still need a pretty high degree of expertise to work in machine learning and AI in finance. And yeah, I mean, if I can narrow the scope a little bit, what is AI? I think that we. So if it's really just sort of observing the present and pattern matching, and then making some decision that accounts for uncertainty and reduces risk, then quant finance has been doing that for forever. Basic portfolio optimization, and this is all of that same ilk. What we're getting a little bit better at, only a little bit, I would argue, is where the problem space is a little bit fuzzier, where that sort of that hidden or that latent layer is more complicated. We're getting a little bit better at managing that, but you still really need, because what we observe is so different from what, say, an autonomous vehicle observes, right? If you take a snapshot of the road and you've got LiDAR, you see what is on the road. But what we can observe about companies from markets is really, really, really superficial. It's just a tiny little bit of the truth. So using expertise to kind of manage the latent space of your models is still really, really necessary. You can't just put your money in the passenger seat and say, get me to retirement quickly and safely and don't crash. It's a long way from that.
So you said something there that I want to just expand on. This, we're only using a portion of it, so we're expanding an existing way of thinking. How about the full transformation? Are you seeing that in the approaches and quantum approaches? For example, one of the things before we had talked about is AI or machine learning models or predictive models helping with how we look at data today, and how we normally do just faster, more efficiency. But are we doing anything more transformational, looking at the data differently? Can you elaborate?
Sure. I think Ashok would be well placed to talk about that.
That was the next one.
Justice for what Andrew said. Let's see. I believe, to me at least, when someone says that I'm using algorithm X and my error rate is 60%, I use algorithm Y, my error rate has reduced to 50%. Yes, great. That might be very helpful in autonomous self-driving car because you could avoid an accident. But in financial market, when we are dealing with the returns that are very noisy and it is kind of changing and etc., I don't think people are using, I'm not saying that people are not using, people are using AI algorithms for the same problem that we were using ordinary least squares and normal arithmetic, and then they are finding better results. But the best bang for the buck for me is finding the areas that we were not able to solve previously, like using text. We were not able to find what is the positive tone of the text by taking into account or the sarcasm and etc. Finding areas wherein we were not able to use simple tools, that is kind of the biggest bang for the buck in my opinion. And whenever people say in the financial context that I'm reducing the error rate yes, you might reduce the error rate from 90% to 60%, but if you transfer that to market with the noise associated with the returns, I don't know if that 30% reduction in error rate is going to be meaningful at all, in my opinion.
I just think, so your question prompted for me this question of like, okay, so what allows us to be sort of fully revolutionary about how we do this? And I think there's an elephant in the room, which we all sort of know about, which is this impossibility of working with the data that we want to work with. And so, and I think your next perspective is very interesting. I could just put you back on the spot, but we're about to go there. But I think, and we were talking about this beforehand, but the infrastructure and the expertise to actually get the really interesting data in one place and make it usable, and then only then be able to come up with your 30% error rate model, which is not so useful, is really a huge hurdle. And I think we're now in this moment in time where an enormous part of being able to effectively, transform how you're doing this work comes down to how effectively can you get your data in one usable place. Is it, and that is both a time and energy question, as well as a how do you decide what to even spend your time on? Because one of the biggest challenges sort of subsequently is, okay, well, let's say it takes an enormous amount of time to, access a certain type of data. Well, how do I know which of my data sets to pick to spend that time on? It's very hard to ex ante guess where the valuable data is. And so I just think that is sort of the interesting, the sort of unsexy but very real hurdle that everyone's dealing with when it comes to trying to do something revolutionary.
That's a very good point, Karen. Like, as I mentioned in the first point, like, there has been the number of data sets available in the market now has exploded in multiple levels, and people are talking about zettabytes and zettabytes of data and lots of data sets. Like, I don't think we are in a position to analyze all the data using the traditional toolkits. So that's one area where AI and machine learning is having a tremendous impact, I guess.
So totally agree. When you ask sort of what's transformational, I think, like, sadly, it's kind of these boring things. Like, what machine learning is good for is a task. I think, I'm also not a computer scientist. You're okay, well, whatever. So we're like armchair a little bit, or I guess we're quants who are like realizing we had to learn these tools. But what I think of is machine learning or neural networks, which actually I did work a little bit with in grad school. I can at least fake it. If a human can do a job well but very slowly, you can make that really fast with computers, and you can make that much, much, much faster than you could 5 or 10 years ago. So if there's some sort of cutoff at which you can't ask a question, you can't process as much data, or you can't do it in a timely fashion where it's relevant to you to then execute some decision. So whether that's routing a call or placing a trade, that time factor of just actually making stuff 10 or 100 or 1,000 times faster, it can suddenly take a set of questions and problems from I can't ask those questions or look at those data sets into I can. So even though you've not necessarily generated some, new lightning insight, you are faster. And if you can find problems where being materially faster has a big benefit, but you can understand the slow version, you can write it out, you can understand it, there's like a common sense reason. So, autonomous driving is a great example, right? If I can understand how to drive a car, I can do that I can do it fantastically well, right? Some people are okay drivers, but I can do it well. So can we automate that with enough data? Turns out we can, right? I mean, I think 10 years ago, I didn't believe it. My husband is an engineer, so he's been telling me for ages, it's coming, solve problem. It's just a matter of regulation. Like, we've got this totally sorted out. But to me, it's those things where it may seem kind of like not that impressive that all you're doing is compressing time. But if it unlocks a new type of data set you can look at, or a new problem, or a new sort of process you can run, that actually turns out to be really exciting.
So, I'm just going to build on a question on something you said, Caroline. You talked about infrastructure and skill sets, so that kind of leads to, and Ashik, you also mentioned that we're dealing with data sets, and so what kind? Can we elaborate a little bit on infrastructure and skill set? And actually, I'm going to mention another thing. I would love to hear your thoughts about human in the loop systems versus black box. And of course, I'm sure the conversation is going to go to transparency, but you know, definitely. Let's chat a little bit about human in the loop because, to your point, Jess, you just there certain things can be automated, but there's a lot of also things where we can't predict. So, is there a place for that versus black box, or what are your thoughts?
So I'll go quickly and pass on. I think a couple of the things you touched on, depending what the application is, you're going to need explainability. Black box is not going to be acceptable. And I actually think there's certain places where a little more black box is sort of okay. Now, maybe it's getting less okay that we're all right with black box serving, me and my next news feed through Facebook. Maybe we decide we don't like that anymore. But for a while, no one cared, right? Served me an ad on the internet. I clicked on it. I bought something. No one cared how that targeted me. That's not true in the financial services space and in managing retirement assets or placing trades, making trading decisions. So I think explainability is important, and it's something we're all going to have to think about from day one as we build models going forward. And then human in the loop, I think that's very case specific for different use cases. What I would say is I think the human needs to be involved in setting the guardrails or the fence around where the model's operating. So if you've ever tried building even like a regression model, if you just sort of throw a bunch of data into a model and then see what comes out of it, you will see something crazy, usually, the first time you build a model. I know one of the engineers we have, Quantopian, has this awesome talk he gave where he just tried to train a computer model to play a computer game that he liked playing, but he wanted to get a better score. And this was his nights and weekends project. So he threw this data into this model, and he got these wild, crazy answers. And what he figured out was that the data set he fed in had like a scale factor problem, and it wasn't normalized, and there was one outlier that caused all the rest of the values to be zero, rounded to zero. So he had fed in effectively like one piece of data instead of thousands. You get crazy answers out, and you need to have a system in place to check, hey, what were the guardrails? Is there a sanity check? Where is this model allowed to go? Do I understand where I'm going to let it, what the fence post I'm going to put around it? So those would be the two thoughts I would have.
With the infrastructure?
Sure. Infrastructure. So we're very lucky at Manumerit to have a world-class infrastructure team. Spark, Hadoop, sort of the core of our stack. Kubernetes, everything you would want there. Scale is really important. Data storage, data access is really important. I don't know. How much? Is there an appetite to learn more about sort of the technical aspects of a state?
Yes.
Okay.
Yep.
Well, let's see. So job schedulers we found to be really important. So we had for a while lots of researchers competing with resources. We've installed job schedulers to sort of free up a lot of extra resources. We're learning ways to again kind of just lower the cost of user access to big data, user access to high compute algorithms. So that's really important. I think infrastructure is it's a non-starter, right? You have to do infrastructure right, but it only gets you in the door.
Just to stress on one more point that Andrew said about infrastructure. I still remember, the days when I used to fight with Andrew. Like, we used to have an infrastructure. We used to adopt AI and machine learning. We will be exhausting all the infrastructure that Andrew will build, and then, he'll be frustrated, and I'll be frustrated. I can't run my algorithm. So after that, we had put a tremendous amount of effort in building credit to the infrastructure team. They have a tremendous amount of effort to build the right infrastructure. These are not simple algorithms. These are, as you guys know, every AI algorithm is running, thousands, if not millions of regressions underneath to just train one model. To run this, you need the scale. And if you don't have the scale to run that kind of a model, then whatever output you're going to get is in many cases, it's going to be worse than running an ordinary least squares. So building the right infrastructure in the first place is kind of a very important piece that I'm kind of happy that the firm was able to tackle, so that I can go and just exploit whatever they have built after that, and then I can look cool in building a model after that. And then coming to the human versus the black box part, I completely agree with Jess. And then I would just add one more point is humans are needed in building these models, definitely, and then putting the guardrails. More so, I would say that human with the right subject matter expertise is needed. So if I'm building autonomous vehicle, I should know something about autonomous. If I'm building financial models, I should know something about finance. And even I would get into the nuances, like I'm kind of a general quant researcher. If my boss asks me to, build a specific model for one industry or one sector, I might not be able to do it until I, learn about that specific sector. Say, for example, tomorrow my boss wants me to build an energy sector model. I'm not a subject matter expert in doing that. First, I have to become a subject matter expert. I should know about that sector. So it's the subject matter expertise that is oftentimes people, overlook that. As Caroline mentioned, they take random forest, they take XGBoost, they take a slew of algorithms, and then they say, okay, the error rate is this, error rate is this, error rate is this. Okay, I'm going to pick the lowest error rate. Okay, perfect. But that's not going to work in the long run. Maybe that time it will work, but that may not work in the long run, I guess. So the right subject matter expert is kind of very necessary in building these algorithms.
I'll just add a few thoughts to it. So I think, first of all, agreed. I think the infrastructure question is table stakes. And what's one of the challenges with it being table stakes is if you're at a firm that is quant oriented to begin with, you kind of have to get over the fact that it's table stakes. You invest in it, you decide you have to deal with it. You're not going to let your researchers actually do research unless you get that right. And so for those of you who are either kind of building a new function out of an existing firm, I was talking to someone just before this about this, and who's in the audience, and I think it's just an important thing to realize. You kind of have to like pitch the rest of your company on it. Everyone has to be on the same page about it, and that actually is also true for this explainability challenge. So there's kind of just the fact of like for things like privacy, et cetera, you need to be able to track down how a given model or whatever is working in a variety of industries. But when it comes to actually also just getting your work done, if you are the quant team or the data science team at a firm that is trying to move into this new era, taking advantage of all the interesting data, you are going to have to be able to explain what your model is doing. People are just not going to accept something that you say like, this is a perfect model, this is a fantastic model, just trust me on it. It's just not going to fly. And so I think the importance of transparency has risen for that reason as well. And the last thing I'll say on the human in the loop, I totally agree. I think another way I would put it is kind of like the maturity of the model also requires, more careful thought around how you build those guardrails. In other words, when you build a model for the first time, whatever the industry, you're not going to have thought of everything you need to consider. And so you do need to feed it some data and see how it goes and figure out what you've missed and add those guardrails. And then you have to, I think about not only as it matures, can you look at it less frequently or less closely or monitor it differently, but also how quickly will the environment around it change so that there's sort of the question of, can it mature and then kind of just live forever in that state? Or will it mature and then things around it will change, so you need to keep examining it? And an interesting example that I always think about, which is actually not in finance, is a company called Drift, which is a local marketing tech company. They have launched an AI bot, and it's really just like the classic. If you go to a website, you see like a little thing at the bottom of your screen that's like, how can I help you? And it's a bot. It's like very often theirs. And previously you had to just like write your own little decision tree of like, if the person asks this kind of thing, or it has this word, like ask this question next. And they launched an AI one about 6 months ago. And what they do is they package it with a human out of the gate. And it's very impressive. It's that they have tracked that it takes about 11 conversations for it to basically run on its own. But they still package it with a person because they know that they don't have it all right yet. And so that person gets to scale with their company. In other words, they can deal with a lot of different chatbots at once because after a little bit of time, those guardrails are in place. it's really a much lower stakes problem than finance or healthcare or privacy, but it's nonetheless, I think, a really it's a very clean example of the way in which you kind of want a human involved, usually at the outset of a model.
So I read an article the other day about a couple of discretionary allocators and their process, and it felt a little bit tummy-feely to me. And so I sent kind of a flippant email to a coworker who responded, well, in fairness to them, they did spend, decades training their own neural nets to make that decision. So I think that model explainability, we hold quantitative models to a standard that we may not necessarily hold people to, which is good and bad. And so when I think about the terms of sort of model explainability, and I think about that conversation, it tends to often be shorthand for do you understand the modes of failure that you're that exist in your domain? Do you understand the consequences of getting something wrong and how that's going to look, and what are the conditions under which you're gonna get it wrong? Have you properly instrumented that, right, to the point that you are confident that you're not going to make that really high cost mistake? And that's when I think conversations about model explainability are really important. When they can, though, however, become incredibly counterproductive when they become conversations about why your model doesn't confirm my biases, right, my human biases. And that's I think that's maybe something that a lot of that a lot of AI struggles against is having some real insight. Maybe they don't necessarily confirm the biases of the reviewer, and then so you sort of move on, but for something it does.
So thank you. I have a couple more questions still, but I would actually would like to open it to the audience. I'm sure you have multiple questions to our wonderful panelists. Questions?
You talked a little bit about ROI. It's relevant.
So let me repeat the question. ROI.
Is ROI relevant to the things you're doing, and how do you look at it differently than traditional investments in new applications or use of resources?
So I think that's a great question. I asked that question of the AI Center of Excellence. One of them is here right now. I asked that question when I got to Fidelity. So they're a fundamental shop largely, and a lot of the AI projects in asset management are in service of increasing the efficiency of a portfolio manager. And so, which is not to say all the projects, but some of them, and some of them that are quite cool and quite effective and work well, people are happy with, are in that space. And I said, well, how do you measure that? And they said, well, if the PM likes it and he uses it, then my model is working. Yeah, that's interesting. So that's one example where I think very challenging, right? But that ROI, if it's Will Danoff and he's moving, billions of dollars, and he does, I think, we could argue about whether he knows what he's doing, but I think a lot of people think that he does. I think that he does. So if you're helping him do his job better and you put a multiplier on that, I think people feel like that's a high ROI and they can construct numbers around it. Much easier from a quant perspective to get comfortable with in terms of measuring is something like, we have a more efficient chatbot, and so we reduced the, threshold at which a customer of a certain account size goes from being profitable to unprofitable for the firm, which is a relevant and really interesting number. That's very measurable, right? So I think it's interesting, and I like the way that Fidelity has approached it, where they have an AI Center of Excellence team that then has sub-teams that face different parts of the business, and each of them thinks about ROI in a different way. So I think it's domain specific and use case specific.
I would also say I think there's kind of different levels of like where and when you measure ROI on these kinds of projects, and I think everything just said is true, not only internally but I think in general. Like it really can be quite specific to the project. At a higher level, I think when it comes to like having that AI Center of Excellence to begin with, it also becomes a strategic question, and so you have to decide like, is your brand, there's so many other components that I think people are to some extent throwing out the ROI discussion with respect to very large strategic decisions. And that's a very uncomfortable thing, I think, as a person running a business or especially a public company, to explain these decisions. And so I think that you end up hearing these earnings calls where people are describing all, the explosion of data much the way we have and quoting all the stats around it, which are really mind-boggling, and saying, okay, strategically, we must be in this game. We will be left behind. And so there is a lot of create the center of excellence, throw stuff at PMs. I'm sort of faking this example because I'm not at Fidelity, but throw stuff at PMs and then say we'll measure it later, or we'll figure out if this will work later. But as a brand, as a company, as a financial institution that exists in 2020, which sort of feels like should be like the Jetsons era, we have to be in this game. And so I would say it's actually a pretty interesting question, but even as attempt to ROI.
Renaissance Technologies has been around for a really long time, and they've got a hedge fund that they have used machine learning and AI for a number of years. So I'm curious, what do you think the reason is as to why it's taken the industry this long to catch up to this? And then on a go-forward basis, how long do you think it's going to take before it fully takes effect?
So I think that sort of to roll this question in with the previous question in terms of ROI, right? We're investing a lot, but it's really, in many ways, it's sort of incremental on top of what quant finance has done for a very long time. So Renaissance obviously has some secret sauce in their Stony Brook campus, but I suspect that what they're doing is not so different from what a number of other quant finance firms are doing. It's just in a slightly different way.
I would just add, I think it's true that Renaissance has existed for a long time, and there are a bunch of sort of peer institutions in terms of longevity. There are very few peer institutions in terms of efficacy, but I think one thing that's interesting is for those who aren't familiar, there is this history in quant, which I think in some ways is parallel to how many new technologies come to markets, essentially, where it sort of had this big rise in the sort of 90s and early aughts. And then in 2007, there was this big crash of the whole quant industry. And it's because everyone was kind of learning in the same way. And what we didn't realize is that all these funds had the same strategies on. So it was essentially crowding. And that the littlest unwind resulted in this massive crash of the whole industry. It was really a precursor to the financial crisis, but it was a full year change beforehand. It was August of 2007. And so I think it's just that also created quite a setback in the comfort and trust using quant. And it also was a huge wake-up call to quants to say, okay, what is actually the way to create something different and unique and that will actually work going forward, and that isn't just based on the same umpteen papers that we've all built our models on so far. So I would say it did have a setback, and it took us, I think, a lot longer to get to where we are today, but we're all much more excited and rallied around it.
So I know Ashok has touched upon this question a little bit, but alternative data, right? How do you guys are leveraging the alternative data at your organizations, and what do you think are the fascinating possibilities that you see with alternative data? And the third thing is, especially in the momentum trading thing, right? It hugely impacts some headline reads like Elon Musk has tweeted something about X, and then the shares have plummeted, something like that. So how do you see the possibilities? Like there is fake news or there is genuine news, and
so one slide that I think I've described to more people than any other slide over the past 2 years is a slide that Quandl, which is an alternative data vendor, showed at their conference last year, which showed the breakdowns of their revenue by discretionary versus quant over the past 5-10 years, right? 5 years, I guess. And what's pretty shocking is that actually they make way more money from discretionary managers than they do from quants. I think largely because quants have been struggling a little bit with understanding how do you deal with these unstable panels? How do you deal with sort of low coverage? When I say low coverage, I mean you might have data for 15, 20, 30 stocks in your universe of 10,000. So quants have had a little bit of harder time investing in alternative data when it comes to the challenges of really trying to have a broad, diversified approach.
I think that's kind of a very interesting point that Andrew mentioned, which is a lot of the data sets, alternative data sets that I have been in conversation with the data vendors that I see, are geared towards fundamental discretionary managers. I believe the reason why I feel that is the case is, let's take the example of Elon Musk or something. What like if there is a data set, that says, okay, it scrapes all the Elon Musk data, tweets, and then it builds an alpha. If you give it to me versus if you give it to a fundamental discretionary manager, the fundamental discretionary manager will be looking at the signal and then seeing, okay, does it make sense? He'll be, he or she will be correlating all the news. What he or she is doing is he's taking the signal as a confirmation for what his bias is. Like, okay, Elon Musk is saying this, is the signal doing right? But what I am doing is I want to build an automated system. I'm a quant. Similarly, a lot of these alternate data providers, when they came, they had a very limited history. Say, for example, there would be very interesting stories. One data vendor came and then they say that, okay, they are going to take into all the geopolitical risk in the world, and then they are going to say that, okay, there is a geopolitical risk in Venezuela, and these are all the gold mines there, and I'm going to come up with a signal for this gold mining company in Venezuela. Oh, that is fantastic. My immediate question was, do you have 15 years of data so that I can go and backtest it? The fundamental manager doesn't ask these questions. Like, he has the intuition about, okay, if there is a problem, I'm going to trade on it. He doesn't look for backtesting anything. But my question is directly opposite. So it's geared more towards the fundamental managers. That raises a challenge for us actually. So there is an explosion of alternative data, and we believe that there is value in this alternative data. It's not like these data are valueless, but we can't backtest it. We can't, do anything kind of a 10-year backtest and then say what is value add or anything. Then how do we imbibe into the quant process? We have to build a system to imbibe even, the signal that are like live for 1 or 2 years. We have to build a system that will cancel out the noises in the Elon Musk tweet and then find the alpha into our process, which is a very big challenge for us currently.
So I think, if I can add one thing, I feel like now I'm going to play like the fundamental manager on this panel, which is not my background. But so I totally agree that the challenge for quants is you need history and you need coverage because you're trying to build a ranking model that ranks every single stock. You need apples to apples. So fundamental managers can look at narrow coverage universes, and they maybe don't need history. But in somewhere like Fidelity, you're a big long only shop. Your main problem is capacity and turnover, right? So, okay, I cannot hop in and out of stuff that Elon Musk is tweeting about and move like $1 billion in and out, right? So the other dimension of challenge with a lot of alternative data, and quants see this too, you create your model, and if it were free and completely frictionless to trade and follow this thing, yeah, sure, it looks like you can make a ton of money. But as soon as I put in either what it would really cost me if I could trade that fast, or the fact that I'm not going to trade that fast, it's very difficult to capture. So I think it's been overall very challenging for the industry to find the promise in the alternative data. I think there's been a lot of chasing it. Our friend Rothman from Goldman had a really funny headline that made it out into the news this week, where he was talking about, the big challenge in alternative data is FOMO, and he's wondering and afraid that people will be trading on lunar cycles in the shapes of faces. I didn't actually. It was paywalled. I didn't read it, but I get his drift. And so I think the thing with alternative data, I gotta say a little bit, is there's a huge machine out there trying to fabricate and sell alternative data, and so what is bigger, the promise of that alternative data for investment, or the industry that's trying to almost kind of create demand for it? And I think there's like a little bit of a conundrum there, I'd say.
Hey, as a portfolio manager, I'm trying to analyze the discrepancy between the actual solutions and the perspective, right? So if you can give concrete examples as to what technology or achievements you're very proud of and what aspirations you have, very concretely, so that we identify this gap that we're talking about. In what way the technology has helped portfolio managers concretely, and where it could help them potentially.
So I think they'll have maybe more tangible examples. Some of the examples that I've seen, and I'll keep my descriptions high level since I'm not sure sort of how specifically we want to get into them. There are, so actually, I think I can describe this in a way that's not going to get me in trouble. So their portfolio managers develop a set, like a style of the type of company they like to talk to. And so a thing that might happen is I'm a PM, I'm going to go to a conference and I only have so many hours available to meet with those management teams and talk to companies. And so I'd like to make sure that if I've got 4 hours to spend, I spend those 4 hours with the right companies to learn whatever it is I want to learn. And so let's say that I would historically run a process where I'd go look at a bunch of their financials. If I could then sit with someone who's going to build a model and I could almost create a supervised learning data set where I say, hey, here's my process. Can I describe it and instrument it in such a way that you can actually run a model on a much larger spate of companies and just try to surface for me maybe companies that wouldn't have been on my radar, wouldn't have been in my universe that I might research. And if those pop up and I look at them and I think they're interesting, so that's an example of a model that I believe I'm allowed to say is running somewhere inside Fidelity today.
I don't know if this may be a too narrow of example, but what I feel is we have done, as a quants, we have done a successful job in using AI is some of the other things that I mentioned in terms of using other forms of data, like having the text data, whether that be from the company filings or from the earnings call or whatever it is, and then harnessing some kind of alpha information, and then using huge databases which were traditionally not possible to use using the normal toolkits. That I believe we have done a very good job of using machine learning and AI algorithms and then harnessing some kind of alpha or other applications from that. The challenges that we feel are similar to what Jess mentioned. Like traditionally, quants have been looking at data that has been covering a broad universe. Like, I need at least 500 stocks or 3,000 stocks so that I can build an alpha. But that might be a data source that is kind of focusing on just 2 companies, but it predicts those 2 companies' net income or the sales or etc. perfectly. How we can start using those kind of data into our quant process, that is kind of a challenge for us. And then the next kind of a challenge for us is, historically, I believe we have been using the data for predicting the stock returns. I don't think it is kind of like everything is going to be kind of a stock return prediction basis. What might, like, even if you think of in terms of a car, like, engine is going to run the car, you need the brakes to apply, put you in the safe mode, you need the steering and etc. Similarly, this alternative data space, like everything we have been just using it to predict returns and then say that, okay, it is working, not working, not working. But I don't think that is the good framework to test all these alternative data space. We have to think about in a collective way, like this data might predict one of the KPIs for this industry. And that KPI is going to predict another KPI. And that will eventually, oh yes, after I have 10 data sets, maybe a collection of all these 10 is going to predict returns. So these 2 things might be kind of the challenges in the quant world for the use of AI, which I guess.
I think these are good examples. The thing that jumped to mind as you guys were talking, I think of like a different dimension, that a place that I've seen sort of being more agile with data or using AI be really effective has been in making much more responsive risk models. So that the sort of corresponding challenges is we still do not have a crystal ball. And so you cannot say that you'll know when correlations will spike, for example. But you certainly can know, for example, that vol moves very fast and correlations move a little slower, and you can decay rate. You can even change the rate at which you decay over time depending on the environment. So there's some really, I think, interesting and very effective ways that we've been able to take advantage of AI. The challenge again is that it still feels always so out of reach to effectively risk manage and construct a portfolio, et cetera. So that's sort of just like yet another.
Yeah, sure. I think they agree with everybody. But primarily, dimensionality reduction has been a real success story. So in the risk model space, that's a huge deal. We've got a lot of noise. you reduce the dimensionality to the point that you can see something in it. But more generally, I think areas where, again, to come back to this term, areas where the latent space is a little bit more understandable, a little bit more manageable. Imagine you're investing in widgets, and the only input to a widget is petrochemicals. Well, you can go back for a quarter and you look at the price of oil, and you can look at labor markets. You can get a pretty good estimate of what the cost of goods sold is for your widgets company before they release earnings. What you can't really do, though, is look in the future and understand that Iran is going to launch some missiles, and therefore next quarter is going to look a little different. So if you can define the space very narrowly, then and sort of avoid these sort of unobserved variables, and like as what Ashok said, maybe total returns is not what we're actually estimating. We're not quite there yet. We can't predict total returns. We can predict some piece of what will eventually lead to a stock having total returns. But even then, there's can't really explain Tesla in some ways. So
I keep giving my short Tesla example. It's never right, but I keep doing it someday.
Yeah, so I actually really like the constant running references to automated cars and automated driving. It's going through this whole conversation. It sort of brings me to an analogy that I tie into sort of the differences that I see between different applications of AI, and sometimes used interchangeably when you actually mean one thing versus another, which is one of the key potential first use cases for automated driving is highways, because it's a much more controlled environment, there's less turns, less cross-cutting traffic, etc. But even that, you can't really fully reduce the risk of that until you have a fully automated car highway system. As long as there's a number of people on the road, that unpredictability means that these models have to be compensating for those things. And so in the same way with discretionary portfolio managers, a lot of that's human psychology, which is very difficult to model. And so until you have a lot more of that decision-making behavior, that discretionary decision-making behavior happening on data that's been cleaned and is being used for more of the automated decision processes of things like index tracking, smart portfolio management, etc., I think that's going to be still very difficult to predict, is how much the market's actually going to move in response to discretionary behavior and actions for portfolio managers, which sort of brings me to the other part, which is my real question, which is there's two applications of artificial intelligence and machine learning, neural network modeling, et cetera. Those are separate but somewhat related to cognitive computing, which is more towards the side of workflow automation, which is you have smart portfolios. This is one application of AI in terms of trying to actually make the decisions or some minimal decisions instead of a discretionary portfolio manager, versus the other application, which you can potentially be using cognitive computing as well as some general models, is intended to make it easier for the discretionary portfolio manager to ingest information, to clean information, to reduce noise, assess risk better, et cetera. In terms of a ratio of what you see in the next 5 years of real world benefit from one of those two applications, what is the ratio that you see AI being applied for workflow management and sort of just giving better data to these discretionary portfolio managers versus actually taking away decision-making behavior from them, putting that in an automated trading fashion?
I worry that we set up sort of an unfortunate straw man that self-driving vehicles are somehow easier. I don't buy that. But to your actual question, I think process automation is really important, and we're seeing a lot of value out of it. But cost saving is maybe in the long run not as important as enabling growth, if that makes any sense. Yeah. So yes, it's really important to monitor your data with AI, or as we might think of it, it's just like very basic econometrics, as it comes into the system, and make sure you flag things that are wrong and you don't use them. But it's also you can automate that away, but that's a cost saving measure versus your other example, which is a little bit more enabling. I think a little bit more enabling of growth and of research.
I agree with that. And the only thing I would add is I think that the sort of process automation work, although there are a lot of things, especially when working quantitatively with finance data, that are specific to finance, the process piece is going to benefit from cross-industry innovation. So it's hard to say like where the sort of ratio of like who's going to kind of benefit from this work more, because I think in the sort of real sort of quant in the sense of full portfolios run essentially without any intervention, with spare exceptions. In that space, it will need to be driven within finance. But I think a lot of the work in terms of just being able to access data, work with data, be smarter about it, and not primarily quant, that will benefit a lot from other industries. So I think it's quite hard to predict because of that, but I think they'll both grow a lot.
I have two questions. One for Quantopian. There's platforms like Quantopian or Quantix that are targeted to individual investors or maybe individual programmers. Hearing about this discussion about infrastructure needs, AI, basically what is left for individual people through a platform like Quantopian to do if there are all these things? And the second question is targeted towards maybe the man-numeric panelists. What can you learn through platforms like Quantopian that applies directly in your work offline? What kind of skills can you learn through platforms like Quantopian or Quantix that you could use in your work?
So I'll start. I think we were talking earlier about how the infrastructure piece is table stakes, and forget the word you used, but you used a word that basically said like it's not your IP, and it is a hurdle. It's a barrier to entry for quant work, but it's not really your IP. The IP comes from being interesting and intelligent about how you use the data. And so that is really the central value proposition of Quantopian for its individual, for the members of its individual community, and also the financial institutions that want to use it. The idea is this thing off the shelf is, it takes N engineers, X years to build this kind of thing. It's extremely expensive. It's labor intensive. But in terms of actually producing the interesting, creative ideas, that is still a source of IP for humans. And to Ashok's point earlier, you need expertise in a given space, whether it's that you're specifically sort of across market, looking at tens of thousands of stocks, quant, or you're a sector-specific oriented person, with all those things. So I would say that, and then I'll jump ahead of you guys on the question of sort of like what can others sort of think about with respect to Quantopians. And you guys will have, I'm sure, a very different perspective. But I think one thing that the thing we aren't saying explicitly about using all these interesting models to work with the disclosure of data is that we're really all just trying to come up with new, better ideas. And so the idea of Quantopian going out to a community of 300,000 plus people is really another way of trying to access new ideas. And so I think that is meant to combat what is a very common construct in quant firms, which is an accidental groupthink effect. If you hire from a certain number, a pretty low number of academic programs or backgrounds, and I had this experience myself, so I'm not purporting it. People produce a lot of value this way, but you end up, there's a lot of teamwork usually in the research process, at least in bouncing ideas and getting feedback and honing the ideas. And so one question is kind of how do you take the, call it bell curve of ideas, and find the tail ideas that don't get chopped off by all that work together. And so that's sort of another way to look at what is Quantopian trying to achieve. And there are a bunch of interesting ways I think various firms are trying to approach that question. But I've now put words in your mouth. That is my perspective.
I completely agree with Karen. One more point is the two things actually. One is the infrastructure, again, very, very crucial. The infrastructure that Quantopian has built is enabling 300,000, did you say 300,000 researchers to put their mind and then develop signals. And that infrastructure, building the right infrastructure is crucial. And then the second thing is, I agree with Carolyn, many of the firms, we kind of have a bias that whatever we build is best. We don't have that crowdsourcing mentality. Like if someone else is building, then we kind of think that maybe it's not as good as what we might build it. But if you really think about it, with the explosion of the data and etc., it's very hard for any one firm, however big you are, to build everything internally. At some point, you have to start believing in this. For Quantopian, it is like believing in the crowdsourcing community. For us, it may be something else. Say, for example, the fintech community is rising. Most of the data vendors are becoming signal providers, not just data providers. Maybe at some point in time, we have to start thinking that, okay, there is merit in the signal that they are providing. And then we have to adopt into our job becomes slightly different as a quant researcher, wherein like we start thinking about how we can build a system which would pick out the best out of these signals and then use it and then throw it away if the signal becomes not useful, something like that.
Thank you very much. I know there's more questions, but I'm cognizant of the time. I want our panelists will be hanging out with us a little bit more, so please catch them afterwards. So thank you very much for joining us for this panel. Varma has a few closing remarks before we give you a few more minutes for network.
Thank you, Denise. Thank you for all of you for coming. It's a great panel and such a wonderful discussions, very specific topics, very specific questions. And this is one of the best event I attended recently. So I give a few points. These recordings will be available on our YouTube channel, the Boston Fintech YouTube channel, pretty soon. We will send you a note when it's available. And our next upcoming event is in April. It's just June. And we are grateful for our sponsors, GSB Labs, Non-Memory, and Unita for infrastructure, providing infrastructure to drinks and broadcast. Thank you all. And please spend some time here networking. And any follow-up questions, we have the panelists, I think. We'll spend some more time here. Thank you.
Yeah.